in the parentheses 2k plus 1, and then close parentheses pi.
Okay.
But the pi is outside the parentheses, not the 2k pi. It's just 2k plus 1 and then parentheses pi. So you, like when you just.
Isn't that what I did? Oh, I see what you're saying. I have this extra pi in here, like a pi square. Is that what you want?
Yeah.
Okay. All right, so tell me why that's right.
So if you look at the sine curve, you have 2 pi, and for your period, I mean, and so like, can I like point to?
Yeah, sure.
And so if you want so you have to like look at, I don't know how to explain. Okay, so you have to like look at the thing, the like period, and because it's on like every one of these is where it's not equal.
Okay, what are you trying to worry about?
I'm trying to explain the 2k plus 1 part.
Okay, because why are we throwing something out?
Because they're asymptotes.
All right, that's right where the asymptotes are.
Yeah.
Okay. All right, so what does k represent?
A constant, like an integer.
An integer constant, right? Not just any old constant, an integer. Oh, Neil?
With the way you wrote it there, you don't have 0 as an asymptote. So wouldn't you just write k pi?
Yeah.
What do you think?
Yeah. Because then when you have k equals 0, that's 0, so you have 0 has an asymptote too.
Okay, and when you put in 2, you would get 2, and 3, you would get 3. What do you think, Rena?
Yeah.
You want to fix that? All right, so we're going to ditch the k pi's. Yes. So what?
I thought it would be k pi over 2.
K pi over 2. Why would it be k pi over 2?
That's fine.
Yeah, I see.
So where are our asymptotes?
Every
At every integer pi, they're at -3 pi, -2 pi, neg pi, 0 pi.
You're not looking at that one?
Oh, no, we're doing this one still.
Oh, okay.
All right. We happy with that? All right, this is a toolkit function, so put this in your collection of toolkits. Okay, cosecant. All right, domain, range, period. What's easy?
Just
Range is the same, right? What's the period? It's also 2 pi, right? All right, here we go with the, Toby, you want to tell me about the,
Oh, okay. So the domain is all our numbers, and x is not equal to k pi over 2.
what do you think? Nothing?
I don't like it because if k is 2, then you have that x is not equal to pi.
Okay, so let's think. This is -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2. What would the next one be? 5 pi over 2, 7 pi over 2. What kind of pi over 2s? How do I see an odd number? Okay, 2k plus 1, or so I heard somebody say 2k minus 1. Is that legal? They're both odd numbers because 2k is an even number, and then says you just subtract one or add 1, and on either side of an even number is an odd number. You know?
Wait, is it divided by 2? Yeah.
I know it's hard to see, so it's down here in the corner. Okay, so it's 2k. So what I've got is 2k plus 1 pi over 2. And that's what I have written down there. X is not equal to those. They're odd multiples of a half pi. Okay? Go.
Could you also say k pi plus 1/2 pi? Or is that something different?
K pi plus
1/2 pi.
1/2 pi.
It seems kind of funky, but
What do you think?
Yeah, didn't you just distribute this time?
So if we took this is
Oh no, we passed the 2.
this is 2k plus 1 over 2 times, well actually, let's go, we will distribute. Okay, let's do that. That's distributing the numerator. And then what could I do? Do I just do this?
No.
No, that's highly illegal, why? Because there's addition on the top, right, okay. But can I do the 2 in each part?
Yes.
And then I would get k pi plus half pi. So, yes, it's a little,
It's a little funky.
it's a little more awkward, but it's fine.
So
It just, I can think about that a lot easier than I can about that, cause that's like, I don't know.
But what does it say?
Well, it's basically,
Power two, so that.
yeah.
Oh, okay,
Makes
yeah,
sense.
all right.
That makes
So
sense
it's
to me
this-
because it's just shifting it over one.
Okay, great, so this one was k pi, and then just go over a half pi.
Yeah.
Okay,
Could you also subtract? Oh yeah, because the same as implying the going.
yep, or another way to think about it is, here's the first one, how far do I have to go to get to the next one? A pi, so every time I have to go a pi. Okay? All right, so that's a toolkit as well. Secant and cosecant are toolkit functions. Now, when you did trig back in geometry, did we do trig in geometry?
Yep.
Yep. Anybody? Rita, you're.
I thought we did in algebra 2, so I don't know.
Oh, maybe you did. I thought you did geometry.
I did in both.
Okay.
A little bit.
Okay. All right. Have we used up all the functions that we learned in geometry trig?
Tangent.
Tangent. Okay. So what was tangent? Which in real life we write tan, right? What's the definition? Alex, you got it?
That's for right angles, that's opposite over adjacent.
Okay, so in a right triangle, it's opposite over adjacent. Can you
Or-
tell it to me in terms of sines and cosines?
That's, the sine over no, it's cosine over sine, right? Right, no.
Did we learn it in terms of sines and cosines in our previous life?
No.
It was freshman year for me, in
Okay,
algebra
okay,
two,
no,
so.
we don't need to make excuses for how, we're old and we
Yeah.
learned it when we were kids. So, I heard you say SOHCAHTOA.
Yeah,
What's the deal with that? TOA.
So sine is opposite over hypotenuse, which is OH, and cosine is adjacent over hypotenuse, which is AH, and tangent is opposite over adjacent, and that's what that means.
So, if this is my angle theta and I'm in a right triangle, and this is A, B,
sine over cosine.
C. Compared with angle theta, you know about this,
Yeah,
this is theta.
Yeah.
okay, yeah, no, I had.
Okay, so which side is adjacent to theta?
C.
See these?
BC, right? Why didn't you say AB?
That's the hypotenuse.
It's hypotenuse, okay, so even though they're both next to theta, the one that's hypotenuse doesn't get to be called adjacent, okay? So this is the adjacent side, this is the opposite side, and this is the hypotenuse. Okay, suppose I looked at sine over cosine,
That's tangent.
okay? Then I would have opposite over hypotenuse divided by adjacent over hypotenuse.
Opposite over adjacent.
Why?
The hypotenuse cancels out.
Okay. Since they're both in the denominator of their respective numerators and denominators, or you could think about this as flipping and multiplying. You could say opposite over hypotenuse times hypotenuse over adjacent.
That's tangent.
So you would get opposite over adjacent, which we said was tangent. So tangent can be defined in terms of sine and cosine. Okay. So for us, I mean, we'll do a little bit of right triangle trig, but we do more function trig in this class. And so for us, tangent is going to be defined as sine over cosine. we took that camera and aimed it there for the last 8 minutes, would that be okay?
I'll do it.
Okay, whose camera is it?
Mine.
Tova's, okay.